Let's begin with the first question. Write the name of the rule which gives the direction of induced current. Option A, Fleming's right-hand rule. Option B, Fleming's left-hand rule. Here, Fleming's left-hand rule is used to find the direction of force, whereas the Fleming's right-hand rule is used to find the direction of induced current. Right-hand rule is used for generator, right? So the correct answer is option A, Fleming's right-hand rule, which gives the direction of induced current. State whether the following statements are true or false. A generator works on the principle of electromagnetic induction. Yes, that's true. Because whenever the conductor cuts the magnetic lines of force, EMF is induced. That is the principle of generator. It is electromagnetic induction. That's true. Option A, true. That's the right answer. When a current is switched on and switched off in a coil, a current is induced in another coil kept near it. This phenomenon is known as electromagnetic induction. Is it true? Yes, this is called mutual induction. That means when a current is changing in the first coil called the primary coil, EMF will be induced in the second coil called secondary coil. Right? This is electromagnetic induction. That's right. Option A, true. Fourth question. A rectangular coil of copper wire is rotated in magnetic field. The direction of induced current changes once in each 2 revolutions, 1 revolution, half revolution, and 1/4 revolution. So you know that when the rectangular coil makes one, that is not 1 revolution, it's half revolution, then the direction of induced current changes in the commutator. Okay, the commutator is the one which changes the direction of the current in the coil. Okay, so half revolution is right. Option C is the correct answer. Half rotation we say, right? The fifth question. The phenomenon of electromagnetic induction is process of charging a body. No. Process of generating magnetic field due to current passing through a coil. No. Producing induced current in a coil due to relative motion between magnet and the coil. That's right. The process of rotating a coil of an electric motor. No. So electromagnetic induction takes place in generator. So option D is also not correct. Option C is the correct answer. Producing induced current in a coil due to relative motion between the magnet and the coil. See, when we keep the coil stationary and we move the magnet into the coil, EMF will be induced. So option C is the correct answer. An induced current is produced when a magnet is moved into a coil. The magnitude of induced current does not depend on. See, when we move a magnet into the coil, induced current will be produced. And this will not depend on what all the factors. Let us see. Speed with which the magnet is moved. That's right. Number of turns. That's right. When the number of turns increases, then the induced current will be more. The resistivity of the wire of the coil. No, it does not depend upon the resistivity of the wire. Then strength of the magnet. Of course, it depends upon the strength of the magnet. So option C is the factor on which the magnitude of induced current does not depend. Okay, option C. That's right. Seventh question. The frequency of direct current is. Options are 0 Hz, 50 Hz, 60 Hz, 100 Hz. For AC, it is 50 Hz in India and 60 Hz in foreign countries. Whereas 0 hertz will be the correct answer, because DC, it will be unidirectional. It does not change its direction. So there will not be any cycle. So no frequency. So 0 hertz. That's option A is the correct answer. 0 hertz. The frequency of alternating current AC supply in India is 50 hertz. It's already discussed. Option B is the correct answer, 50 hertz. At the time of short circuit, the current in the circuit, option A, reduces substantially, does not change, increases heavily, varies continuously. No. Reduces substantially. No, it will not reduce. It does not change. Increases heavily is the correct answer. During the short circuit, what happened? Heavy current will be flowing. So it will increases heavily. Option C is the correct answer. 10th question. See, a magnet is moved into the coil and the coil has been connected to galvanometer shown in the figure. It's moving towards the coil. The galvanometer gives a reading to the right. What is the name of the effect being produced by this moving magnet coil? What is this process called? Just now we have seen electromagnetic induction. Option A, electrochemical induction. Option B, electromagnetic induction. Option C, magnetic effect of current. And option D, heating effect of current. Option B is correct, electromagnetic induction. A coil is connected to galvanometer. When the north pole of the magnet is pushed into the coil, the galvanometer deflected towards the right. What deflection, if any, is observed when the magnet is at rest in the coil? See here, the same diagram. So when it is in motion, we find that when the north pole is inserted into the coil, then it deflects towards the right side. But when there is no motion at all, what will happen to the reading in the galvanometer? It will show 0 deflection. That means no current, EMF will be induced. No induced current flows. So no deflection in galvanometer. Option B is the correct answer. A coil of insulated copper wire is connected to galvanometer. What will happen if a bar magnet is pushed into the coil? Just now we have seen, right? A momentary deflection is observed in the galvanometer, indicating the production of momentary current in the coil. That's right. There is no deflection in the galvanometer, indicating that no current is produced in the coil. No, that's the wrong answer. The deflection of the galvanometer is in opposite direction, showing the production of an opposite current. That's also wrong. Option A is the correct answer. A momentary deflection is observed in the galvanometer, indicating the production of momentary current in the coil. Option A is the correct answer. A coil of insulated copper wire is connected to galvanometer. What will happen if a bar magnet is held stationary inside the coil? Just now we have seen. If it is held stationary inside the coil, what will happen? It will show no deflection. Okay, there is no deflection in the galvanometer, indicating that no current is produced in the coil. That's right. So option B is the correct answer. A galvanometer is an instrument which can detect the presence of electric current in the circuit. Okay, it will not measure the current. The one which measures the current is ammeter. It detects the presence of electric current. That's the function of galvanometer. Option B is the correct answer. Fleming's right hand rule is also known as dynamo rule. That's right. Is it true or not? True or false? Yes, of course it is true. Right hand rule is for generator. It's also called dynamo rule because it is AC generator. We call it as dynamo. Generator, we name it as dynamo. Whether AC generator or DC generator, dynamo we call it as generator. Generator is called dynamo. The other name for generator is dynamo. So it's true. What do you mean by self-induction? Self-induction means when, we'll see the option. When the current flowing through a coil changes, then the current is induced in the coil itself. This is called self-induction. Second option, when the current flowing through a coil changes, then the current is induced in other coil. It's called self-induction. When the magnetic field changed in the coil, then the flux changes in the coil is called self-induction. None of the above. See, what is meant by self-induction is whenever the current flowing in the coil changes, then EMF will be induced in the coil. That means there will be change in the flux linking with the coil. So EMF will be induced in the same coil. That is called self-induction. So option A is the correct answer. Whereas second one, change in the current in one coil will induce the EMF in the other coil, means that is mutual induction. It is not self-induction. Option B is wrong. When the magnetic field changed in the coil, then the flux changing in the coil is called self-inductance. That is not said to be self-induction. Okay. So whenever the conductor cuts the magnetic lines of force, EMF is induced. That is called just an electromagnetic induction, but it's not called self-inductance. Okay. So option A is the correct answer. Which of the following is the method for inducing current in the coil? How to induce the current in the coil? Beating the coil into the thin wire? No. Removing electrons from the coil? No. By inducing it with the help of magnet? By changing current in another coil placed near it? No. Yes. So option D is the correct answer. By changing the current in another coil placed near it, we will be getting induced EMF or induced current by inducing it with the help of magnet. How we will induce it with the help of magnet? By moving, we will say. Okay, we have to move the magnet, only then the EMF will be induced. So option A, B, C are wrong. Option D is the correct answer. By changing the current in another coil placed near it, then what is produced? Induced current will be produced in the coil. Clear? We have discussed various objective type questions on electromagnetic induction and generator principle. If you like the video, kindly click the like button and share to your friends. And subscribe the channel to get notifications for the upcoming video. Thank you for watching the video.